Hi, my name is Deborah Fowler, and we're continuing on with the snowman in Python. Last time we did loops, this time we're doing functions. So I've got the same code that we developed in the last video, and if I go ahead and run this, you'll see that we get a nice little procedural snowman. And what we're going to do now is generalize this, so we're going to tidy up our code a little bit. Add a function. We add a function by using the word def, and then a name called snowman, and then some parameters that we're going to send. We put a semicolon, and we take and create the scope of the function, or the body of the function, to be indented. So what we're going to want to send in here is all of the information that was coming from these values in here. So we're going to send in a start position. I'm just going to call this start, and I'm going to change these values a little bit. So wherever we see start, we use that. And I'm going to also want to send in the size. I could use these same words, but rather than using the same words, just to keep it clear, I'm just going to call this size. And then I'm going to call this shrink. I'm going to use that there. The reason is I want to keep these variable names the same up here, just so you can see what happens. So start, size, and shrink are the parameters of our function snowman. So we're using the size of the snowman that we're going to send in. So in here, or the snowball rather, when I call the function, I'm going to call it with arguments. So my arguments are going to be start position, snowball size, and shrink factor. So I just changed those words to make it clear that I'm using these values here. Let's just move these here. Here. These values are just calls to this function. So start position is a value minus 300 and so on. Those values then get passed into start, size, and shrink. And those are the values that are used within this function. So if I run this, I've now got a function definition. I'm going to add a comment here. And I'm just going to say draws snowman for now. And we'll just run this so you can see what happens. We've got exactly the same thing we had before. Now it's embedded in the function. Now we could go one step further, because what we've got is these values, start, size, and shrink, are local to this particular function. So that means that these values in here are used inside of here, but not anywhere else. So if I, for example, tried to say print start, this would give you an error. So let's go ahead and show that. You can see what happens is it says start, name start is not defined. So it's working because, of course, we're still sending in and doing our function. But when it gets to here, when it gets to this line, so it's drawn the snowman, when it prints start, it doesn't know what that is, because that's a parameter which is local in scope to this function. Okay, so we're talking a little bit about scoping of variables. If I printed start position, it's fine because this is actually a global variable, which we don't really want. We want to hide this in the function so that we can't get at it in this file. So if I'm going to just demonstrate this, so I'm talking about scoping of variables, and I'm also talking about functions. You can see it printed out that value. So these are variables that are in this file, but we want to encapsulate them. In other words, protect them in another function. And we're going to call this main. The reason we call it main is from convention, from other programming languages. And let me just tab this in so we know what the body of this main is. And now, if we run this, nothing would happen, because again, we've just defined a function. We need to call it. So we're going to go ahead and call this function. You can see here we're calling main. And in fact, we could even put the turtle into main to be cleaner, even cleaner. And let's just get some spacing here. Now, Snowman isn't going to know what the turtle is, so what we're going to do is send in turtle t. For right now, I'm just going to leave it the same name. And this defines turtle inside a main, but then sends it to snowman in the parameters. So now, if we run it, everything should work. And you can see that we have our snowman. We're still printing out that word. Let's just go ahead for that value. Let's go ahead and run it without that. And you can see that everything works. So what we've done is we've encapsulated our code essentially in little modules. And it's really good to create modules because then what we can do is test them and use them in a larger program. So what we're doing is taking the steps to start programming modularly. So another thing I want to show is that we can also input these as values to our function, but we can input these from the user. So let's go ahead and do that. We're in Python 3. So Python 3 actually creates an input that is a string. And recall that Python isn't strictly typecast, but we need to know what type the variable is. So we're going to have to convert this because we're using values rather than strings. So these are numbers. So let's go ahead and do one. Let's do start position. So what I'm going to do is give the user some information, give them a heads up about what I'm going to ask for. So I'm going to say start position. Instead of -300, I'm going to say go ahead and input okay. And I'm going to leave a little space there. And what's going to happen is it's going to wait for me to enter that number. Now, if I ran this right now, it would cause a problem because it would think it was a variable, a string variable. So if I do this, you can see I'm going to enter the value, and I'm going to go ahead and say -300. And you see all sorts of errors. The problem is, in this version of Python, that value is a string, and you can't use a string inside an expression here for start. So what we need to do is change that, and in this case we can use an integer, or we might want to use a float. So what we're going to do is convert that from a string to a floating point number, and that will allow us to use it. So if we run it now, we have entered value, and we'll use the -300, and it goes ahead, and we'll just close this so we can see it, and drew our snowman. So that's essentially how I can input data. Let's do it again. And since we're using all of these as numbers, I'm just going to go ahead and do this. Enter the value for the snowball size. Okay. And in this case, we may actually want to suggest values. So -300, for example. And then this one, we might want to say 100. And then in here, we'll do this as shrink factor. So what you're doing is you're allowing, again, one more level of generalization so that the user can decide what those values are. Now, obviously, you want to give the user some hints, especially if you've created your size of your screen to be a certain size. We're using the default right now. Then you want to give them kind of a heads up so it doesn't go out of screen. So I'm going to enter my value for the start position and my snow size and my shrink factor. And if I look over here, you can see that it drew this. So continuing on, there's a couple of things that I would also add to this code. Turtle.exit on click allows us to cleanly exit the window, whether we're using an IDE or not. So I would add that as well. And you can comment these out while you're debugging, while you're working, just so that you don't have to go back and forth between inputting each time you run it. It can get a little bit tedious. So I'm just going to comment out those for now. I know that they're working. And then go ahead and run this to make sure everything's fine. And you can see that now it's running, and when I click on the window, it exits properly and cleanly. So those are just things to know. One other thing I want to mention, sometimes you'll see code that brings in the turtle separately from the window. So it was bringing the turtle, and I said turtle.screen. This works perfectly fine. It's just another way of doing it. But now if I run this, this is going to fail because exit on click isn't understood by the pan. So if you look at the error message, it says, oh, exit on click doesn't exist. And the reason is we didn't use the screen, we used the pen. So I could just change that here. And that works as well. So I just wanted to go through, you can see there's no error messages in here. I just wanted to go through that in case you see that or you want to use it, that's fine too. You will probably see that in your third exercise. I'm going to get rid of that and just go T and turn this just to a general turtle, and that's fine too. Okay, so getting that back to working, and I want to do one other thing. I want to talk about the window setup. So we so far have been using the default, but you can also do a setup of the window. You can determine what size it should be. So we can say turtle.setup, and then let's say we make it a skinny window, 300 by 800. So we're determining what the window size is. I wouldn't recommend going past 1280. Well, 1920 would probably be okay, but you can see here that now we've got a window size of 300 by 800. And you can go one step further. You could actually make that dependent on your actual size that you select. And of course, you want to warn your user to not make it too big. But let's say that we wanted to do that. We would move this command to below where we're reading the variables. And then we'd set up the window before, right, we actually drew the snowman. And we should add comments in here as well. So this would be obtaining input from user. And this would be setting up the window. So it's important to also make your code readable and understandable. Okay, this could be initiating the turtle and so on. So what would happen if we wanted to calculate it? Well, for one thing, we could make it based on the snowball size because we're making it based on his bottom radius. So we could do that. And we could just add a value in here, let's say a bit of a buffer, okay, just so that we aren't snug against each of the bottom of the snowman. That's a little bit snug because I forgot to multiply by 2 because this is a radius. We want the diameter. Neaten that up a bit. And go ahead and run that module. And you can see that now we've got breathing room on both sides. This one is, we're still hard coding it. We could calculate that. So let's set that up. So if we wanted to, instead of using start position here, we could calculate it as well. But let's first start with this. We're going to say y value. So if we said y value equals 800, that's just using a variable, right? So that's fine. But what we want to do is calculate it. So we're going to set up a function. We're going to have a function which is going to be called calculate height. So in here, we're going to calculate height. And I'll just call it calculate y. We need the size and the shrink value. And then we're going to use this. Basically, this whole thing that we're using here, we use as a sum. So sum, we're going to start at 0. And then we're going to create a loop, just like we have up there. And then we're going to add to that sum the size times 2. And then we're going to shrink that size. And that should give us the snowman size. But we want to return that value to where it's called from. So in other words, when we do y value, instead of setting it to 800, what we're going to do is call calculate y with the snowball size and the shrink factor, because that's what my function is expecting to get. So those two values. And that value that it's returning is then put into yval. So that becomes the value of yval.
So that gives the calculated value of approximately the height of the snowman. And I'm just going to add a little bit of wiggle room in here for the screen. And then we're going to go ahead and run it. And you can see this right now is not centered because, of course, we still have the start position here. We could actually calculate that start position. Let's go ahead and do that. So I'm going to comment this out. We don't have to have the user enter it. What we're going to do is take that y value and make this the start position and take y value times a half, but we do know we want to go in the negative y direction. And then that becomes our start position. And we could also neaten this up a little bit so it's a little more readable, so that we have our obtaining user input, and then we could have calculating our height and so on. And then you can see when we run this that we have our snowman with a little bit of breathing space on both sides. We can expand this a little further. So we could also add another argument. So let's do a number of snowballs. And we're going to obtain that maybe from the user. So let's do snowballs. And this will now be, say, a 5. And this should not be a floating point. We are going to use an integer, so it makes more sense. And we'll change this to snowballs. And the example would be for the user, say 5. And then we're also going to do that for the snowman itself. So if we change the arguments, we need to change what's receiving the parameters in the function. So let's call this just num. And num is going to control my loop. And same thing here. And here. So we're sending in that value and we're receiving it, and it will draw. So let's go ahead and run this. And it shouldn't break anything. It should be exactly the same. So let's change this value, make sure it's all working, to 7. You can see that we're all good to go. So we can comment in those user-defined controls, and then we've got a modular setup with a function called snowman, calculate y, and main. And we can run this with or without user input, and we've got a nice little window that centers on our snowman. Okay, so that's functions. I hope you've enjoyed this and hope to see you again soon. Bye for now.